Hello, today we have to see what is the answer question which is included in the assignment of data MCS-208, that is data structure and algorithms. Assignment number is PGDCN new 2 oblique 208 oblique assign dot oblique 2025. The question exactly is what is a doubly linked circular list, that is DLCL, and what are its advantages and disadvantages, and we have to give a scenario where its application is appropriate, and after giving this appropriate scenario we have to justify our answer. So let us first see what is DLCL, that is doubly linked circular list. A doubly linked circular list, that is commonly known as DLCL, is a variation of a doubly linked list where the first node is connected to the last node and the last node is connected back to the first node. In other words, the last node's next pointer points to the first node and the first node's previous pointer points to the last node. This creates a circular structure allowing traversal from any node in either direction. What is the structure of this DLCL? That is, each node has a data field that stores the value, a next pointer that points to the next node, a previous pointer that points to the previous node. The head points to the first node and the tail points to the last node. The tail's next pointer points to the head and the head's previous pointer points to the tail. Now let us see. Let us now deal with the second part of our question that requires us to answer about what are the advantages and disadvantages of DLCL. So let us first talk about the advantages. Advantages of a DLCL, that is doubly linked circular list. The first advantage is it is bi-directional traversal. Since each node has both a next and a previous pointer, you can traverse the list in both directions, that is forward means from head to the tail and the other is backward, that means from the tail to the head. Efficient insertion and deletions is the second advantages of the DLCL. Insertion or deletion of a node can happen in constant time, that is O1 O1 O1, especially when you have direct access to the node where you want to modify. There is no need to traverse the list for such operations, unlike an array or a singly linked list. The third advantage of this, which is useful in scenarios like buffering and round robin scheduling. The next advantage or the benefit is it is no pull pointers. In a circular list, you don't need to worry about null pointers when navigating to the next or previous elements. It's always guaranteed to loop back to the beginning or the end depending on the direction. The next advantage we can list is flexibility in algorithms. That is, a circular list allows for certain algorithms like round robin scheduling, circular queues, and a circular buffers to be implemented more efficiently. Now, let us see what are the advantages of DLCL. The first limitation or the disadvantage we can call it as increased memory usage. Each node requires extra space for the previous pointer in addition to the data and the next pointer, which increases memory consumption compared to a singly linked list. The other disadvantage of this structure is complexity in implementation. Managing the circular nature and properly handling cases like traversing past the head or tail, especially during insertion and deletion, can be more complex compared to simpler list structures. The third disadvantage is higher overhead in pointer management. Maintaining both next and the previous pointers, along with ensuring that the list remains circular, that is, when nodes are inserted or deleted, requires additional logic. The fourth disadvantage of this structure is potential infinite loops. If not properly managed, the circular nature can lead to infinite loops during traversal. For instance, if a traversal mechanism isn't designed to handle the circular structure, that is not checking for previously visited nodes, it can lead to issues. So these are the advantages and disadvantages. Its application is appropriate. Its application means the application of DLCL is appropriate and we have to justify our answer. So let us see if scenario where a doubly linked circular list, that is DLCL, is appropriate. The scenario is round robin scheduling in operating systems. In operating systems, round robin scheduling is a method used to allocate CPU time to processes in a cyclic manner. Each process is assigned a fixed time slice and the scheduler cycles through the processes in a circular manner, restarting when it reaches the end. Now, why DLCL is appropriate for this scenario? The first appropriateness factor is circular nature. The circular structure of the list aligns perfectly with the round robin scheduling algorithm. Once the last process is reached, the scheduler back to the first back to the first process automatically. The second appropriateness factor is efficient insertions and deletions. In a round robin queue, processes can be added or removed as they enter and exit the scheduling cycle. The doubly linked nature ensures efficient insertion and deletion without needing to traverse the entire list. Bidirection traversal is the next appropriateness factor. The ability to traverse in both directions could be useful in certain situations where the scheduler might need to modify or adjust processes based on execution time, priority, or other factors. Why this is justified? Let us put our justification. The circular doubly linked list structure allows for efficient scheduling where every process gets a turn and the scheduler can quickly move between processes without the overhead of restarting or reinitializing pointers after reaching the end. This structure optimizes both space and time efficiency in maintaining the scheduling queue. So now let us summarize our answer. In summary, we can say that a doubly linked circular list offers benefits like efficient insertions, deletions, and bidirectional traversal. Its circular structure is particularly useful in scenarios where cyclic behaviors like round robin scheduling or buffer management are required. However, its increased memory usage and complexity should be considered because these are its limitations or these are its disadvantages. So one has to consider its increased memory usage and complexity, and both these points should be considered when deciding if it's the right choice for a given application to use the DLCL structure or not. So, and for that, we have prepared a very compact yet meaningful and very attractive write up or answer, whatever you may say it. So, this is the summary part which summarizes what we have been trying to put forward in our detailed answer, which we have just read, understood. Thank you.